So today we're going to be talking about power series, and as you can see, this is the normal form, where this right here, C of n, is a sum, and then it's going to be x minus a to the nth power. This can be written as, so it doesn't have to start at 0, it could start at any value, but in this case we can write it like this, or this would be like the other form, right? And then you can have like plus, minus, anything. That's all irrelevant. So in this form, right, this is the first time that we've seen x instead of just n's. And x here is used as a variable, right? So it can be any value, and you want to be able to see what values of x this sum here will converge to a number. So once you do this, right, so it's actually easier if we work this out like a problem in this case. And then I can be pointing out the different parts of it. So an easy problem that we can work out here is let's just write down example 1 and then 2 to the n over n times 4x minus 8 raised to the n. It's the sum from n equals 0, n equals 1, to infinity. And we want to see for what values of x this sum here would converge. So the easiest method when given a power series question, especially in this case, is either the root test or the ratio test. So in this case, you can't take the nth root of just n to the first. So you would have to use the ratio test, and then that would equal to the n plus 1 times 4x minus 8 to the n plus 1 over n plus 1 over 2 to the n over n times 4x minus 8 raised to the n, right? So then that equals 2 times 2 to the n times 4x minus 8 times 4x minus 8 raised to the n times n, because you would have to flip this over and then multiply, over n plus 1 times 2 to the n times 4x minus 8 to the n, right? Now, if you can see here, oh, and then the sum will still move over here, but we can disregard that for right now. And wait, no, that's actually incorrect. It's the limit as n approaches infinity. Limit as n approaches infinity, right? Because the ratio test means that you need to have a limit sign over there. So then these two will cancel, these two will cancel. And then you're left with, let's move this right here, limit as n approaches infinity, for what's remaining, 2 times n times 4x minus 8. Over n plus 1. So as you can see in this case, it's n approaches infinity, so the 4x minus 8 is not going to be changing, right? So you can move that out here. So then you'd be left with 4x for 2n over n plus 1, which equals 2 because of, okay, you know what, let's just use L'Hopital's rule, which equals 4x minus 8 over 2 times infinity plus 1, which is indeterminate, so then it'd be 4x minus 8 times the derivative of 2n, which is 2, over the derivative of n plus 1, which is 1, which equals, okay, now we've got to move down here. So 4x minus 8 times 2 is less than 1, right? Because that's literally what the, what's it called? Oh yeah, that's what that is called. The ratio test, right? Because it needs to be less than 1 for it to converge. The absolute value, actually. That's very important because now you're going to be getting a balance type thing with the lower and upper bound. So now to find what values are acceptable, you have to so it'd be 4x, you can rewrite this as right, because that's how you do. And then you can pull 4 out from here. So now we're going to be approaching on our first big thing on power series. You see here, the x minus a type thing, what this tells us is what our center is, right? So our center is actually 2 because this value would have to equal 0. So then the center, here, I'll write everything out, all the big things out at the end somewhere. And now you can divide both sides by 8. Is less than 1 over 8. This value right here is our radius of convergence, or the r value in this case. And then 2 is greater than negative 1 over. Right, and now you can just solve this, right? So then you would get x is less than 17 over 8, and then x is greater than 15 over 8, right? So now we have all 3 values, right? So our center equals 2. If you remember at the beginning, it was given in the form of c of n times x minus a, right? And the center is always equal to a, because that value will always make it equal to 0, right? Because if it's just the sum from any number to infinity of 0, then that's equal to 0. And now you get your radius equals 1 over 8, because that's the value that we found here. In our form of x minus a is less than a number, that value right there is the r value, and it's the absolute value. And then our intervals we haven't found yet, because we know the 2 things, but now we need to check the upper and lower bounds, right? So let's test this out. So 17 over 8 times 4, 17 over 2 minus that. So one of them is 1/2 to the n, and the other one is negative 1/2 to the n, right? So if you plug that into here, so it'd be the sum from n equals 1 to infinity, 2 to the n times 1/2 to the n over n, and the sum from n equals 1 to infinity of 2 to the n over n times negative 1/2 to the n. So this converges because it's it's the alternating p-series, and that's a simple one. And this one, harmonic series, and then this one does not converge because this one is just your harmonic series. So our interval convergence is inclusive of the 15/8 because we proved there that this value converges. So it'd be inclusive 15/8 to 17/8 exclusive, or you can rewrite this as 15/8 is less than equal to x, which is less than 17/8. And then this is like all the values of x that you can have that would allow this sum right here to converge to a value, right? So we figured out what a simple power series is, and now we are going to do another problem. Okay, first let me erase all of this. Here, let's do 4 to the n times x to the n over n, and it's the sum from n equals 1 to infinity. Okay, you know what, that's an infinity. We can all tell. So we can do this as, so you've got to use the ratio test again. Oh, wait, no, we skipped a test here. We skipped a step that might not seem that important, but is probably very useful during tests. So you want to be able to rewrite this in the form of c of n times x minus a to the n, right? So in this case, a is actually equal to 0. So that's equal to 4 to the n times x minus 0 to the n over n. Now that might not seem useful right now, but when you're taking the test, you should always remember that x can equal a, so you don't want to be making any mistakes. So that's why you should be rewriting it like this. This isn't necessary, but it's a good habit. So now you can do the ratio test. And then you can flip and multiply. As n approaches infinity. N times n. Right. You can cross out everything. So now what you're remaining with is you're remaining with times x minus 0 times n over n plus 1. And it's the limit as n approaches infinity. So now we can take this here. And you can see, right? You can pull the x minus 0 out in front. Again, because it doesn't have an n term in it, so it doesn't matter. So now you're left with 0 times the limit as n approaches infinity of 4n over n plus 1, and I think that it's redundant using L'Hopital's rule here. This approaches 4, so now you have x minus 0 times 4 is less than 1, because that is a requirement for the ratio test for it to converge, right? So now, let's find our r value, right? Since you can't factor anything out of here and it's already in the x minus a form, you just need to divide it by 4. This is the absolute value, again. So now you have, wait, no, first let's rewrite this. So now you have 4 times x minus 0 is less than 1, and then 4 times x minus 0 is greater than negative 1, right? And now we can divide, move it over. So now you would get your radius and your center, right? So we can write down our center equals 0, and our radius we are about to find. We can move this over, and now we get x minus 0 is less than 1 over 4. That's our radius value, because now you have c of n is less than a value. Radius equals that, and x minus 0 is greater than negative 1 over 4. And then now you can solve for x, and since it's minus 0, it's around 0. So now you get negative 4. So now you get, our numbers are negative 1 over 4 and 1 over 4, right? But now we need to plug it back into this to check. So let's do that. So you get 4 to the n times 1 over 4 to the n. And then this value over here is divided by n. So this is just a harmonic series, so this diverges. And now you get 4 to the n times negative 1 over 4 to the n over n. And then this converges because, again, it's the alternate harmonic series. So our interval of convergence is negative 1 over 4 comma 1 over 4 close parentheses, or negative 1 over 4 less than equal to x, which is less than 1 over 4. And then that is how you would solve a simple p-series. And now I meant power series. Same thing. Let us move on to the more difficult parts. Wait, I need to be able to find. I need to find some problems.